Hi, math students. It's Mrs. Marcellus and my very wise friend, Euclid. In this lesson, we're going to learn to find the area of parallelograms. Today's learning objective is students will find the areas and missing dimensions of parallelograms by creating models and applying formulas. Before we begin working with parallelograms, I think it's important that we review some basic vocabulary that we'll be using. First of all, area. Area is the number of square units needed to cover a surface. When working with geometry, your answers must have a label. The labels help identify what you are finding. Area always has a label of units squared. The word units is just a generic name for whatever unit of measurement you're using. For example, it could be inches squared or centimeters squared, etc. Because we'll be basing the area of a parallelogram on the area of a rectangle, it's important that we review that as well. We can see that we have 10 squares in each row, and there are 5 rows of 10 squares. A much more efficient way to calculate this is to multiply 5 times 10. In doing this, we're multiplying the length times the width of our rectangle. We also often call this the base times the height. So what do you think, Euclid? Are you ready to move on to parallelograms? All right, then let's proceed. Before we start calculating the area of parallelograms, let's first take a look at its identifying properties and features. A parallelogram is going to have opposite sides that are parallel. Parallel means that if we extended the sides on forever, they would always be equidistant apart. A parallelogram has opposite sides are congruent. This means that the opposite sides have the same length. Sometimes we see that noted with congruency markers that look like this. The matching pairs show that those opposite sides are congruent. The opposite angles in the parallelogram are also congruent, and they would be marked like this. This can be really handy when we're trying to find missing measurements. In a parallelogram, the base can be any side of the parallelogram, and a height connects the two bases together. In this example, we can see that we would consider the top and the bottom to be the bases, and the dotted line is the height. A height and a base always meet each other at a right angle. They are always perpendicular to each other. Let's see if we can figure out how to find the area of this parallelogram. One thing we could do is count up all of the individual squares. However, we can see that we have several half squares. We could piece those together to find the total area, but we have to remember that our figures are not always going to be drawn on grid paper. Therefore, we're going to need to find a common formula. We can do this by adding a height to the parallelogram. We can then cut off that triangle, and we have a shape that looks like this. We can move the triangle we removed to the other end of the parallelogram and reattach it. When we do that, we can see that we now have a rectangle. We can easily calculate that we would have 21 square units in our rectangle. And because we created that rectangle from the parallelogram, we know that that has to be the area of the parallelogram as well. It is true that every parallelogram can be turned into a rectangle. We can always take the height and cut off a piece and move that piece to the other end. Our formula of area equals base times height will hold true for all parallelograms. This formula also can apply to the square and the rhombus. Let's find the area of the parallelogram. The area is the base times the height. The base of the parallelogram is 12 centimeters, and the height is 11 centimeters. We will multiply 12 times 11 and find that the area is 132. And of course, we must apply a proper label, and that would be centimeters squared. On this parallelogram, the height is drawn on the outside, but that doesn't change anything about the way we calculate the area. We will multiply the base times the height. The base is 6 inches, and the height is 9 inches. So the area will be 54 inches squared. This parallelogram is a little trickier because we're given 3 dimensions. We first must determine which is the base and which is the height. The height connects 2 bases. The height and the base always meet at a right angle, and they are perpendicular to each other. We can see that the 15 feet connects 2 opposite sides. 15 is going to be the height. The 2 bases are the 2 sides of the parallelogram that are connected by that dotted line, and they are both 2 feet. We're going to multiply 2 times 15. We don't use 17 because that is a slanted side, and there is nothing that connects that side of the parallelogram to its opposite side. The area of our parallelogram is 30 feet squared. In this parallelogram, we are asked to find the measurement of the missing base. We can use our formula to figure this out. We know the area is 36 and the height is 4. We can write 36 equals b times 4, or we can use the commutative property to switch it around and write 36 equals 4b. We can divide both sides by 4 to find that 9 equals b. The length of the base is 9 yards. When you are labeling a single dimension, you use plane units and not units squared. You also could solve this using mental math pretty easily. You just ask yourself, what times 4 equals 36? Let's use our formula to find the missing height of this parallelogram. We know that the area equals 60 meters and the height is missing, so the question is, which number is the base? Is it 5 meters or 16 meters? By definition, the height connects the bases, and we can see that the dotted line connects the bottom to the top. Therefore, the base is 5 meters. 16 meters is simply the length of the other side of the parallelogram, so we won't use that in our calculation. 60 equals 5 times h, so we divide both sides by 5. The height is 12 meters. A parliament, or group of owls, hunts a territory in the shape of a parallelogram. The base of the area is 7.5 miles, and the height of the area is 4 2/5 miles. What is the area of their territory? One strategy is to draw a picture of the parallelogram, and another strategy is just to pick out the dimensions that you need and plug them into the formula. Since we've done several problems with pictures, we'll just work with the words. The problem tells us the base of the area is 7.5 miles. The height is 4 2/5 miles. So I'll have to multiply 7.5 times 4 2/5. In order to multiply these fractions, we need to convert them to improper fractions first. That would leave us with 15 over 2 times 22 over 5. I can cross-cancel the 5 and the 15. 2 and 22 also cross-cancel. When I multiply straight across, I get 33 for a numerator and 1 as a denominator. The area is 33 square miles. A second way to do this calculation is to convert the fractions into decimals. You will also get a result of 33 miles squared. So, Euclid, are you part of a parliament? When I hear the word parliament, I always think of a bunch of people in formal outfits and those white powdered wigs. I think that'd be a good look for you, don't you? No? Well, just saying. Anyhow, math students, that concludes finding the area of a parallelogram, so we're going to wave bye for now.